Guys, everyone before going further, give the heading of the question. Main book. Everyone before going further, main book part 2. This is what, guys, chapter number 11. Chapter number 11, question number 4, guys, everyone. October 2012 exam, question number 6. Yes, in this chapter, there is nothing to memorize anything. Everything is concept based. If you understand the concepts of components of a force, how to take a moment, all that things, then you will get the concept, guys. Otherwise, this chapter is very, very difficult. For few people, they feel this chapter is very simple. For few people, very, very difficult. Now you have to identify you are in which category. Now everyone try to see the scenario here. What they are asking us, guys, everyone, in this question, we have what? Short vertical hollow cylindrical column, everyone. What we have, guys, everyone? Short vertical hollow cylindrical column, 160 hollow cylindrical column. Hollow means what? Circular, hollow circular cross section, 160 mm high. So height is what, guys, everyone? 160 mm. This is what height, 160 mm, and fixed at the base. So it is fixed at the base. They are saying 70 mm outside dia. So capital D is how much, guys, everyone? 70 mm. It means what? 0.07 meter, capital D, outside dia. And thickness is what, guys, everyone? 8 mm. So small d will be what, guys? Capital D minus T. Is it okay? Capital D minus T, everyone? 2T. Guys, you have to tell me, 2T, remember. Otherwise, in hurry. So 70 minus 2 into 8. How much, guys, everyone? 54 mm. So it will become what, guys, everyone? 0.054 meter. So we got it. Then height, we will show that height on the. Then carries a concentrated load of what, guys, everyone? 10 kilonewton. See, 10 kilonewton of load is here, everyone. See, at an angle of what? 45 degree, and we have another load, 6 kilonewton. It is a vertical one, everyone. So before going further, everyone given the heading of the question. Always before reading of the question, always give the heading of the question, guys. Keep a practice like that. So now before going further, please everyone write down these 3 given things, and then we will see further also. Very simple question, guys. Nothing much in this question.
So we need to draw the diagram?
No, not it. Not it. No drawing, guys. Only write down these 3 things. I will tell you which diagram we have to draw. I'm going to draw that diagram, and then you have to draw, guys. Because here the most important thing is components of a force. Everyone, now try to see the scenario here, how we are going to approach. So what we are going to do, we are going to draw the drawing of column. Always try to draw the bigger drawing, guys. Don't never draw the smaller drawing, guys. Bigger, like your home. 1 minute. So here we have what, everyone? This is what a column, guys, everyone. Observe a column. Column is what, guys, everyone? Tell me. It is what? Hollow. So hollow circular means what, everyone? So from this point I am going to draw one dotted line, everyone. This is invisible to us. See, if you know the basic drawing concepts, and if you want to show inner portion which is not visible, how we are going to show that inner portion which is not visible? With the help of dotted line, guys. You may have read these things, means in your shape drawing also. If you want to see the drawing of any pump or like that, a portion which is invisible, dotted line, guys. So there, then important thing will be what, guys, everyone? This will be what? Center line of the what? Center line of the column. 1 minute, let me make it as a properly vertical line. I will take it as a reference, and I am going to make it as a proper vertical. So this is what guys everyone, center line. Now the next thing is what, cross sectional area. So how we will to denote a center line guys? Bigger line, smaller line, then bigger line. Always we will follow the standard practice guys everywhere. This is the standard things guys for any. And remember important point in drawing, sorry, in mechanics, what is the most important thing guys everyone? Drawing. Second important thing is unit. So these are the two important things. Now then one dotted line from here. Observe here this dotted line. What is the purpose of this dotted line guys? To show the cross section. So here 1 minute, let me draw this one as a dotted and then I am going to copy that one. What is the purpose of this dotted guys? To show the cross section guys everyone. And here another dotted. The purpose of this dotted line to show the cross section. And here what cross section we will have guys everyone? Circular, hollow circular. So observe guys, important suggestion from my side. If you have a how to draw this one, first of all always draw the cross section and then from cross section draw that one. And guys purchase the stencil guys, means where we will have a different shape, different circle. See one stencil you will get only circles, purchase that one. Another stencil you will get a rectangular like this, there you will have a circle, rectangle, triangle, a different shape like this. Purchase that both the stencil guys everyone. One is only circle, another all the shapes guys purchase that one guys. It is very helpful for you. Your speed will automatically get increased guys because of that one. And always whenever we have to draw this one drawing guys, first of all draw the cross section and then extend the line and then complete the remaining. Things will become very easy. So this is what everyone. A cross section of the what guys everyone? A circular cross section of the column, hollow circular cross section. And here this is what we are going to show by what guys everyone? Hatching. The importance of hatching is what? In this portion what is there guys everyone? Material is there. Now in this view, this is what guys everyone, tell me. This axis is denote what? Neutral axis. And distance of outer fiber from the neutral axis will be what guys? This distance will be what everyone, tell me. So this distance is what guys everyone?
Y max.
Y max. 1 minute, let me draw it properly guys. So this distance is what guys everyone? We will show it as Y. What? Y max. Then here this is what? Outer dia guys everyone. Outer dia is what? Okay, capital D. Then we will have what guys everyone? So here we will have what? Everyone, this will be what? Inner dia. Inner dia will be what guys everyone? Small d. Now what is thing is missing here guys? This column is what was at the bottom? It is a fixed one. Fixed at the bottom. So how to show the fixed one guys? Whenever we want to show fixed one, always show this hatching guys at the bottom. It means what? That bottommost portion is what guys? Hatching, fixed one. So that is meant by, and other end is what? A free. Now here what we have guys everyone? So here we are showing. Here two things are for the support purpose. These things are what guys everyone? Support purpose. What name we can give guys? This one, can anyone help me? Collar. Okay, consider it is like a collar. So here collar is for what? Support. But here guys don't worry about collar. Here we don't have to do anything with the collar. Everything we have to deal with what? Only collar. So collar is only for the support of the loads guys. So now everyone, so this is what I am going to show the collar here. Everyone observe. Don't write anything. First of all, let complete your teacher I will give you a time to write down the things, guys, huh? Because in initial days, when I am telling you, means my initial day I have observed, those students who write with me, at the end they will have a lot of doubts, lot of the confusion. So then I made a rule, compulsory, nobody should write in the class, guys, huh? When I am drawing the things. So this is what, guys, everyone observe. So this is what a color is there. Everyone getting my point? Try to understand the scenario. Anyone have any doubt in this discussion? Now the story starts from here, guys. 1 minute. Let me minimize a little bit. Now here we have what, guys, everyone? Two forces. One is what? 10 kilonewton. Another one is what? 6 kilonewton. Now here if you observe, this 10 kilonewton is what? Inclined one. Whenever we have an inclined force, guys, we have to replace that inclined force by what? Its component. You remember that basic theory video, guys? I told you. If you have not watched that video, please watch that video once again. Then and only you will understand the concepts of components, guys, huh? Everyone. I made that video available for you guys so that you can watch that video anytime. Whenever you get confused how to take a components, go that video, watch that video once again, and you will get understanding of components. Huh? Now here, if you remember that discussion, see, there are 4 ways to represent the components, guys. Huh? There are what? 4 ways to represent the component. 1 minute, I am going to that basic theory. And 2 rectangular ways, guys, everyone. 2 rectangular ways and 2 triangular ways. But if you have a given force, from a given force, we want the components. Guys, I remember my point. It is not a rule, guys, but generally we prepare like that. Your teacher is going to prepare like that. When we have a force, and from a force, see, 2 story will be there. We have a force, and from a force we want to find out its component. Suppose Fx and Fy. We have a force, and from force we have to find out what? Components. Then we will prefer rectangle. We have a components, reverse story. We have a components, and from a components we have to find out its main force. Then we will prefer what, guys, everyone? Triangle. That is what your teacher is going to prefer, guys. And why he is going to prepare? Because things will become very, very simple, guys, if you prepare that way. Remember, we have a force and we want to find out components. Then which way we will prefer? Rectangle. And why we are preferring a rectangle, boys? Because if you are preparing this rectangle way, taking a moment will become very, very simple, guys. If you prefer a rectangle way, taking a moment will become what? Very, very simple. We have a components and we want to find out a force. Then Pythagoras theorem, sin theta, cos theta will become very, very easy, guys. Sin theta, cos theta, tan theta, and then things will become very, very simple. So that's why we have a component, then find out the force. Then we will prefer what, guys, everyone? Triangle way. We have explained that one also. Now, guys, everyone. Now here we have what, everyone, in this question. In this question of what, guys? I am coming back to the question of the eccentric loading, everyone. I am coming back to the question. Here we have what, everyone? We have a force F. We have a force F. Force F is what, guys? Okay, 10 kilonewton. It is inclined one. And we want to find out its component. How to find out its component? Which way we will prefer? Rectangle way. Because from a given force, if you want to find out components, which way we will prefer, guys, everyone? Rectangle way. Now in rectangle way also, guys, we have what, everyone? 2 options. In one option, force is going outward, components are going outward. In other option, everyone observe, force is going inward, going inward. Now out of that, which way we will prefer here, guys, everyone? First way or second way? Can anyone guess?
Second way, sir.
Coming force is coming down.
See, guys, everyone,
Yes,
remember,
towards us.
if force is going inward toward the object, guys, see, observe. If force is going inward, means what, everyone? Just imagine that. Here this F, this 10 kilonewton is what, guys, everyone? What is happening? This 10 kilonewton inward, going towards the object. Guys, if it is like this, guys, 1 minute. Here different scenario is there. Observe this question. Here, this force is what, guys, everyone? Observe. in this question. We will deal this with question, guys. In this question, going outward. Then
Upward.
which way we will prefer? First way. Force going outward, components go outward. If force go, guys, there is another numerical. Everyone, one more numerical. No, other numericals are homework for you guys. Everyone. So now here, see, here force is what? You got the meaning of inward and outward, guys. Everyone, remember this one. I will take one more numerical. 1 minute. I will go to the chapter of the friction. Just imagine that. Suppose this ladder numerical. 1 minute, guys, everyone. Now tell me, this RNB, this force RNB is what, guys, everyone? Going inward. Then its components also what, guys, everyone? Observe. Inward. That is meaning of the inward, guys, everyone. You got the concept? So, guys, please, if you have not watched that video of basic theory, please do watch that video. Then and only you will understand my concepts. Otherwise, everywhere you will going to get confused. So now everyone try to see the scenario here. So now 1 minute, guys, I'm coming back to our question. So now here we have what, guys, everyone? 10 kilonewton. I'm going to show by generally try to show the forces by a red pen, guys. The things will become very, very simple. So this is what 10 kilonewton, guys. Always try to show the bigger, guys, everyone. Components, all that thing. This is what I'm going to make it as little bit dark. Now this is what our everyone 10 kilonewton. And now everyone, how to show the component, guys? To show the components, what we are going to do? We are going to form a what, everyone? This rectangle. What we are going to do, guys? What we are going to do? We are going to form a what, everyone? Rectangle like this. Observe the things here carefully. So this is what a rectangle we are going to form. Whenever we want to make a component, guys, always make a rectangle. So I'm going to make it as what? This dotted rectangle. Observe. Once you make, and remember, this rectangle is only, guys, sometimes I have observed my lot of students how they will make a rectangle, guys, everyone. A force goes like this, or force goes like this, exactly like this only, within the given force, everyone. Observe. And now this 10 kilonewton is making how much angle, guys, everyone? 45 degree. This angle is what, guys, everyone? 45 degree. Observe. So now here, as force going inward, components also goes what, guys, everyone? Inward. So one component like this, everyone, little bit dark, so that it is properly visible. 1 minute, I am going to make it dark. Is it visible, guys, this component? See, remember this point. Your component should not be like this. This is, or should not be like this. Wrong thing. Exactly what, guys, everyone? Within a what, everyone? Within a rectangle, not outside the rectangle, guys. Exactly on what? At the edge of that rectangle, guys. Exactly at the edge of the rectangle. This is one component, and another component will be what, guys, everyone? Tell me. This is the another component. Observe. Observe the thing, guys, everyone. So I'm going to make it as a little bit dark. Now now what are the things here, guys, everyone? This value of this component will be what? 10 cos 45 kilonewton. So whatever angle, guys, here angle with respect to what? Horizontal one. So this component, horizontal component, will become what? Cos. Guys, cos. Then another component will become what, guys, everyone? 10 sin 45.
Sin 45.
So 10 cos 45, 10 sin 45. Remember this one. So here angle with respect to what, guys, everyone? With respect to horizontal. So horizontal will become what? Cos. Another one will become what? Sin. Remember, whatever the angle. Guys, suppose just imagine that. Here, just imagine that, suppose this is a force here. and we are taking its two component. Guys, for that one I'm making a rectangle like this and I'm showing the component here. Okay, just imagine that. And we are taking angle theta with respect to this one. Then this vertical component will become what, guys, everyone? F cos theta, and this horizontal component will become what, guys, everyone? So whatever angle, guys, with respect to what, that component will become cos and another one will become what, guys, everyone? Sin. Remember this, keep always this thing in your mind, guys. Always. We will prepare this one also, guys. If you remember, I will go one more question, guys, so that you will get a more detailed understanding. See, 20 degree cos sin. 1 minute. That same friction question I'm going to go. We will deal with this question also, guys. If you remember, see here. This 12 degree with respect to what, everyone? Tell me. 1 minute. I am going to enlarge this view so that it is visible. Now visible, guys, everyone, properly. 12 degree with respect to what, everyone? Vertical. So horizontal vertical component will become what? Cos 12, and horizontal component will become what? Sin 12. We will see these things in our upcoming discussion. Story is not that much simple, guys, everyone. So now I am again coming back to our eccentric loading question. So here we have a component, guys. Then this distance is how much they have given us, guys, everyone? This distance, tell me, everyone. This distance, how much they have given us, guys, everyone? 50 mm, 50 mm. Observe, guys. This distance is what? 50 mm. Then we have what? Another force is there. What force we have, guys, here? At the other side of the collar. This is what, guys, everyone? What we have? 6 kilonewton.
6 kilonewton.
So another force will be what, guys, everyone? 6 kilonewton. And this 6 kilonewton will be what, guys, everyone? Tell me, from here to here. What will be the scenario, guys, everyone?
50 mm.
So same 50 mm.
Same 50 mm. That is also given, guys, everyone. So these are the things for us, everyone. Then what is the missing from, guys, here? What I have not shown on this drawing, guys? Can anyone help me? Something is missing from this drawing, guys. Can anyone help me? Height of the column, correct. What is missing, guys, everyone? Height of the column is missing. And how much height of the column, guys, we have, everyone? Tell me.
60 mm.
Height of the column is what, guys, everyone?
160 mm.
160 mm. Height of the column is what? So this distance will be what, guys, everyone? 160 mm. So before going further, guys, what you have to do? Draw this figure, guys, properly, everyone. Everyone, this figure is visible properly?
Yes, sir.
Good, guys. So please, everyone, draw this figure properly. Guys, one important instruction, everyone. 1 minute, guys. One important instruction, guys, for everyone. Whenever we want to show the hatching, suppose this is what our circle, guys. Don't show hatching like this. Should be what, guys, everyone? One direction only, And generally we prefer angle of 45 degree, guys. Don't show the hatching. This is the wrong way, guys. This is the correct way, everyone. Don't show the hatching, guys. Sandeep sir.
Okay.
Okay. Whenever we want to show the hatching, only one direction, guys. So now, everyone, what we have to do? See, whenever we have to start here this numerical, guys, everyone observe. Right, check it, whether you miss anything, whether you have written all the things or not. So now try to see the scenario here. What we have to do? See, two things are important here. Why two things are important, guys, everyone? One is what, everyone? Two things are always important here. One is what? To calculate the value of F. And another thing is what? To calculate the value of M. What are the two things are important in case of the eccentric loading? Force F. Which forces creating a direct stress and which forces creating the moment, guys. So F and M. So now everyone, which forces here are creating a compression, guys? Tell me. Which forces? Now replace. Guys, 1 minute. Now here, guys, this is roll of 10 kilonewton is get finished. 10 kilonewton is replaced by what? Its component. Means like, guys, see, when your parents got retired from everything, their property or whatever their business automatically transferred to what, guys? To their children. So role of the parent get finished, and who is going to come into the picture, guys? Their children. So children are what, guys? Everyone tell me. Components are, guys. Components are the children. So this is what the father, parents. We will not say mother or father. We will say simply parents. So parent and his or her children. Everyone. One children is this one. Maybe one is girl. Another one is what, guys? Boy. We can say like that. Everyone. It is not always that we have a girl, boy. Everyone. But a simple story we can make it like that. So this is what. Now tell me. Here, which forces are creating a compression? Guys, 1 minute. What is the meaning of compression? Decrease in length. Which force is creating compression here, guys? Here we have total
10, 9, 45 and 6 kilonewton.
So which forces here creating compression, guys? 10 sine 45, 6 kilonewton. So these two forces creating a what, guys? Everyone, compression. So you have to check it, guys. So if it is a compression scenario, you have to check it. Which force is creating a compression? Is this force 10 cos 45? Is it creating a compression?
No.
It is not a decreasing a length. It is not a changing a length of column. It is going to bend only to bend the column, guys. Everyone. Here what is going to happen here, guys? Everyone. Only what? Bending of the column, everyone. So then, guys, everyone. So then F will be what, guys, here? 10 sine 45, everyone. 10 sine 45 plus what, guys, everyone? 6 kilonewton, everyone. So only forces, guys, here, because we are seeing which forces creating a compression here, decreasing length. So now everyone tell me.
Sir, 13.07110.
13.071.
07106.
13.071.
06. 1
071.
01.
Unit? Kilonewton?
Kilonewton.
But
Yes,
what
sir.
is our favorite unit, guys, everyone? Newton. So 13.071 into 10 raised to the power 3 Newton. We got it, what, guys? Yeah.
Answer correct. 14.56.
10 sine 45. Complete the bracket. And complete the bracket, guys. And plus 6. And press the SD. 13.071. Correct, guys.
Okay.
Complete the bracket, guys. Sometimes what we will do, guys, everyone? In hurry, 10 sine 45. What calculator will do, guys? After you press sign, it open the bracket. And in hurry, what we will do? Instead of completing bracket, wait. So it will become 10 sine of 51, guys. We don't want that one. We want 10 sine of 45 plus 6. Everyone.
Okay, why not? It's in radian.
You completed the bracket?
Sir, my mistake, sir. The calculator is in radian.
Okay. And guys, you have to check it that one also, guys. At the top of your calculator, there is option is D. So remember, keep your calculator in D mode, guys. And how to reset your calculator, guys? If you don't know, shift, then 9, shift 9. After that, 3, initialize all, and then equal to, guys. Shift 9, 3 equal to, and then after that AC. This is the reset your calculator for the what? Who is using 991 EX or ES, same thing. So now everyone try to see the scenario here. Now we got it, what, guys? F. Now what is the next important thing is what? How to calculate a M. Guys, everyone. That is the most important scenario here, guys. How to calculate a F. M. How to calculate M. Now here everyone, whenever we want to calculate in case of the eccentric loading scenario, we always calculate a moment with respect to this bottommost point. This is like a cantilever beam scenario, and I told you for a cantilever beam, maximum bending moment is what, guys? At the fixed end. But in fixed end also, which point you have to select? Center point. Guys, remember this point. So you have to take a bending moment with respect to what, guys? Everyone tell me. With respect to bottommost, that fixed support, this point, guys. Everyone, fixed support this point. Everyone at this red point in your drawing. Everyone at that red point in your drawing. Make it as a red, guys, so that it is properly visible. About this point, we are going to take a moment. So what we are going to take a moment, guys. Everyone, observe the scenario here. So about this point, we are going to take a moment. Now everyone, if force is going to pass through the center line, no moment due to that force. Now here in this case, don't consider sagging and hogging. It leads to a confusion, guys. Here story of sagging and hogging get finished, guys. How to take a moment? We will assume clockwise as a positive and anti-clockwise as a what, guys? Negative. In this case, story will become very, very simple. Don't consider sagging and hogging in this scenario, guys. What you have to consider? One is a one positive, counterclockwise negative. Consider this story, guys, for this upcoming discussion.
So we need to take moment or bending moment?
Basically it is a bending moment only, but we will say it as a moment. Means bending moment is a combination of moment, na?
Yes, sir.
Whenever we see it is a bending moment only. But here for this one, for this eccentric loading scenario, always consider what, guys, everyone? Or whenever we have eccentric loading or cantilever scenario, guys, only one end fixed and other end free. Always consider, guys, what you have to consider. If you are considering one direction positive, another direction will become what? Negative, guys. And always try to take a moment, guys. See, if you remember our discussion, guys, everyone, of this one, deflection of beam, I told you to consider sagging and hogging there. If you remember, I will come back to that discussion of the sagging and hogging. 1 minute. I told you what I told you here, but don't worry about this one, guys. Here only we want value. And how to get the value? Just F and distance. F and distance is what? F into 2.2, 2.8. Then effect of the UDL. Guys, see, one question that I am going to send you a solution today from the chapter 5. Whenever we have a cantilever scenario, guys, always don't worry about the hogging and sagging. Just try to take an effect about what, guys? Fixed edge. If you are considering one direction, there try to consider clockwise positive, anti-clockwise negative. Guys, always try to keep this one in your mind. Whenever we have a cantilever scenario for the calculation of what? Bending moment, everyone. Here we are calculating bending moment. So when I am going to send you solution of that question, guys, today, 1 minute before going further, so that you should not get confused. See, that is the scenario, guys, in that question. This is the scenario. When I am going to send you question in, this is what a F, this is what a suppose UDL. When I am going to show, while calculating M, I will not consider sagging hogging. What I am considering, guys, directly, guys, F into L plus W into L into L by 2. Because I want here both effect in the same direction. And I want, what we want? Only value of M. So if the both effect in the same direction, no need to worry about the sign, guys, everyone. So while I am sending you the solution, guys, or if you see my previous solution of any question, guys, of related with cantilever beam, don't worry about sign convention there. You have to see, what you have to see? If both are creating the same effect, F is going to bend a beam in this way and W. So we want only value of M, maximum bending moment. And how to get the value? F into L, moment of F into L. Moment of F is what? F into L. Moment of this UDL, W into L into L by 2. So while I am doing that one, guys, I will use only this one. Don't worry about sagging, hogging in case of the what? Cantilever beam, guys. In case of the cantilever beam, everyone, you don't have to worry.
Make a note. You can make a note.
Yes, I will. For cantilever beam, you have to don't worry about sagging and hogging, guys. You have to see means one direction you will consider, means here if you consider clockwise effect positive, then anti-clockwise effect we will consider negative. If you consider clockwise negative, then clockwise will become anti-clockwise will become, and counterclockwise will become positive. That is what you have to do. I will give you a note after this numerical, guys. Everyone, don't worry.
Okay.
But you don't get.
But sir, excuse me, sir.
Yes, sir.
Sir, in case if we are if we are taking this as a moment, m as a moment, then can we substitute the value of m into that bending moment equation?
See. Basically, I told you, guys. This is not a yum. This is not a simply moment. This yum is a bending moment only, guys. Remember, say everything, guys. I'm telling you, everything in the class. I'm not going to tell you. See, guys, everyone. Whenever there is a, guys, few more things. As you ask me a doubt, there is always more things are there, and I'm not always leave all, means I will not open all my cards at a stage. If you ask my doubts, then and only. See, guys, see this. Though I am showing all the forces here, not all complete forces. Here, whenever there is a fixed end, at the fixed end, there are few things is going to develop. One is what? Whenever there is a fixed end, few things is going to develop. One is Rx, one is Ry, and one is a what? Moment reaction is going to develop. And that is not our area of interest. So, guys, here, this is not a yum, simply yum. This is a bending moment only, guys. Remember, and bending moment is a summation of moment. Don't consider here only simply moment. If I am writing capital M in case of the bending equation or this discussion, though I am saying a moment, it is not a moment, guys. This is the bending moment. And here, don't worry about a sagging hogging. What you have to worry? How to calculate bending moment here? Clockwise, anti-clockwise. That you have to consider. Then things will become simple. If you have a normal beam where we have two supports, then consider a sagging hogging. There sagging hogging is important, guys. But in case of the cantilever beam, cantilever means what? Fixed at one end and other end free. Then what you have to consider? Clockwise, counterclockwise. And here, Santosh Dada, you are getting my point. What I want to say.
Yes, sir. Yes.
This is not a moment, sir. This the expression that I have written here for this cantilever beam. This is not a moment, sir. This expression. This is a bending moment only. But here you don't worry about the sign, sir. Here, if all these
sir, as per your explanation which you gave yesterday, that was also very much perfect, sir.
Sir, but remember,
in
sir.
Case
See, in everything, I know what explanation I have given to you yesterday, that is also perfect. But it is related with that issue. But now, story is going to get complicated. And if you follow that expression, it leads to a confusion, guys. Everyone, if you go to that expression, it leads to what? Confusion, and we don't want confusion, guys. So here, at the end, what we need, guys, everyone, we need a value of m. So you have to check it. And then you have to consider according to that one. Santosh Dada, you are getting my point. So,
yes, sir.
Okay. So, guys, everyone, remember this one. Whenever we are going to deal with cantilever beam, always remember maximum bending moment where we will have at fixed point, and in fixed point also at the center of there we will say, guys, everyone, means whenever we want to take a moment, everyone. So we will coming back to our question now. So where we will take a moment, guys, everyone. And one more thing, when I am going to send you that solution, guys, everyone, when I am going to send you that solution, I will directly consider this one only. So you don't have to consider, don't worry about sagging or hogging here. Directly I need a value of m, and how to get the value of m in that equation? F into L, W into L into L by 2. And both directions are in the same way, so we can directly add them. If the directions are different, then opposite direction effect will be, I will subtract, guys. But here both the direction effect is same, and we will see that one in upcoming discussion, guys.
Excuse me, sir.
Yes, sir.
Sir, like in this question, only question number 5, what you were telling. If suppose we have used this sagging hogging, and we have got minus, then we have written it is minus because it is the hogging, and then further we have used the positive value only, like we were doing yesterday. So that will be marked okay.
Yes, that will be marked also okay, sir. Nothing will happen. But when the solution that I am going to send you, sir, in that one, I will not write down hogging, sagging. I will simply write down what expression I will write down for M, sir.
This one.
You have into L, and that's why I have not given you that solution, guys, because I want to explain you few more things, whenever
Okay,
I
okay.
huh.
So if we minus, then the value will be less. So
See, suppose instead of, sir, guys, there is one more extra force. If you are adding one more extra force here, F1, F2, then see, other maximum forces in which direction? Clockwise, and this is on opposite, so minus F2, and this distance, suppose imagine that this distance is what? X.
Okay.
F2 into X, then minus.
But that question, both are going downward.
Both they go, means both the effects, don't say downward, both the effect is in clockwise direction. Okay. So that's same effect. Then we have to worry about sagging, hogging, guys. Why we need only what we need, guys, everyone, at the end we need a value of bending moment. At the end what we need, guys, sagging and hogging is important where when we have what two supports are there, then their story is a little bit complicated. There we need a sagging, hogging. But whenever we have a cantilever beam, there is what story is not that much complicated. Story is very, very simple. One direction consider as a positive, means we will consider generally prefer clockwise positive, counterclockwise negative, guys. Everyone remember my point. We will see.
So one last thing. So you mean that if it's a cantilever, suppose it is more than two forces, like two forces are downward, one or two forces are going upward, like we have shown here also. So in that full scenario, we can apply this clockwise, anti-clockwise formula.
Yes.
In case of cantilever, right?
Yes. We will see the whenever while calculating bending moment, we will not see the direction clockwise. Hogging, sagging. We will see clockwise, anti-clockwise, guys. Clockwise, counterclockwise. Everyone. Whenever. Yes, sir.
In this case, also the submission of moment across the fixed point will be 0.
How it will be fixed point? How I'm telling you now, guys. Here the forces that we are showing, it is not a complete force. How it is a 0, sir, fixed point? How it is 0? There are few forces at the fixed end also, guys. The reaction forces is going to develop. That we are not showing.
Okay.
Guys, what I am telling you, at the fixed point, always remember, in case of the cantilever beam, we will have a maximum bending moment. Where bending moment is 0, at the free end is a 0. At fixed end, it is not a 0. You will say, sir, how? Because at the fixed end, you will say, sir, at other side no forces are there. There are forces on the other side also, guys. We are not showing, because whenever we have here, guys, everyone, whenever we have what? Fixed, guys, some reaction forces is going to develop. Rx, Ry and moment reaction is there. But that is not our area of interest, guys. So that's why. Otherwise, you will say, sir, this side no forces, and how it is maximum here? There is a reaction forces are there, guys. But we are not showing that reaction forces. So, but here, everyone, now, guys, we will come back to the question, guys. So, now the next thing is what, guys, everyone, to take a moment. The moment theory is quite important, guys. We will generally follow. It is not a rule, guys. We will generally, guys. See the wording. So generally, we will follow clockwise effect positive, counterclockwise effect negative. Just imagine that, guys. Now, and about which point we are going to take a moment? At the mid of the fixed support, guys. Everyone. Now, what is the?
Say that neutral axis, sir. Can you say this point as a neutral axis point?
Yes, you can say it as a neutral axis point, but don't go. Now this is more than sufficient, sir. Few more things are there, Michael, sir, but that is not our area of interest, Michael Dada. Okay. Okay. So, guys, everyone, now try to see the scenario here. So this is what our everyone 6 kilonewton. Now about this point, what is the effect of 6 kilonewton, guys? Clockwise, counterclockwise? Clockwise, Clockwise. So 6 into what? 10 raised to the power 3. 6 into 10 raised to the power 3. Perpendicular distance is what, guys, everyone? 50 or 160?
50 into 10.
50 or 160, guys. Perpendicular distance of 6 kilonewton with respect to is what? 50 or 160?
50.
50 mm.
50 mm, guys, don't get confused. So your teacher will try to confuse you. So then into 50 into 10 raised to the power minus 3. Then next thing will be what, guys, everyone? Next effect, 10 sin 45. What is the next effect? 10 sin 45. Clockwise, counterclockwise? About this point.
Counterclockwise.
Counterclockwise. So what? Minus or plus? Minus. 10
Minus
10 sin 45 into 10 raised to the power 3 because Newton into 50 into 10 raised to the power minus 3 in meter, guys. Force is in Newton, distance is in meter. Now 1 minute, don't write anything, everyone. The next thing, guys, we are not considering parent role get over replaced by his or her children, everyone. So now 10 cos 45. 10 cos 45 effect about this point will be what? Clockwise, counterclockwise, everyone? Clockwise. So positive, negative? Positive, everyone. So 10 45 into 10 raised to the power 3 for Newton, and perpendicular distance with respect to this point will be what, guys, everyone? 10 cos 45.
160.
Guys, see, 1 minute. This is the most confusing part, and that's why I told you to watch that video how to take a moment, guys. And again I'm coming back to that one, to that basic theory, how to take a moment, guys. 1 minute. Where is a moment, everyone? Where is a moment? You have written that moment also there, na, guys, everyone? Yes,
After
moments are
non-concurrent forces.
yes, moments are there, guys. See, moment of a force. Just observe here, guys. Take out that heading, guys, if you have written that one. Moment of a force, everyone. You have written?
Yes, sir.
Okay, guys, good. So, see, extend this line. How to take a moment? This is a line of action of F. Extend this line. About this point, suppose about point O, we are going to take a moment. So, force into what, guys, everyone? Perpendicular distance. F into what, guys? D. So, moment will become what? F into moment of force F about point O will be what, guys, everyone? F into D. Now, just observe the same thing in this one, guys.
That is 160.
Now, observe this one, guys, everyone. I know this is the confusing, guys. In my initial days also, I also going to get confused. See, extend this line. Extend this line, just. Extend this line. If you extend this line further dotted and draw one perpendicular line from here, what will be that distance, guys, everyone? Tell me. What will be? 50 mm or 160? 50 or
160.
160, So remember, guys, everyone. So, don't worry, guys. You will get an expert in these things. So now, this plus 3, this minus 3, we can cancel, guys, everyone. Same. Then this plus 3, this minus 3, we can cancel. This plus 3 and this minus 3, we can cancel, guys. And everyone, please do the calculation. Everyone, please do the calculation.
One 1077.8174. 77.8174
8174 Newton meter. And as we are getting a positive, means what? Effect is in which direction, guys?
Clockwise.
Clockwise. It means what? Our given beam is going to bend is what, guys, everyone?
The right side clockwise.
Like this, beam is going to bend what, guys, everyone? Like this. Now, guys, here, just imagine that. Instead of positive, just imagine that we got a negative value. I'm telling you one more scenario also, guys. Suppose we got it a negative value, 8174 Newton meter. Then what we will write down? We will write down, after getting negative value, we will write down positive value. I told you what we need, value and its direction. So instead of clockwise, overall effect will be in what, guys? Anti-clockwise direction. And then in that scenario, beam is going to bend in which direction, guys? Everyone tell me. In the opposite direction. So that is what you have to remember, guys. And now you tell me why these things are very, very important for us, guys, everyone. Why direction of this bending moment is very, very important, and why it is necessary to need it. Means if you have a positive value for this given scenario clockwise, it means what? Beam is there is a bending is going to generate. Means here, guys, I am telling you two effect is going to generate due to these three forces, everyone. Due to these three forces, what are the three forces? 6 kilonewton, 10 sin 45 and 10 cos 45. These three forces create two effects. One is what? Decrease in length of the column, means compression of the column, and another one is what? Bending of the column. And with the bending, we will come to know that as this column is going to bend, guys, as this column is going to bend like this, what is going to happen? At these points, guys, everyone. At these points, what is going to happen, guys? Everyone tell me which type of bending stress
Compression.
which type of bending stress is going to develop, guys, everyone? Maximum compressive bending stress. Which type of bending stress is going to develop? Maximum compressive. But its value is what, guys, everyone? F max only. Now, everyone, at these points, everyone, at these points, observe this one. At this point, everyone, this is the red point that I have shown you on this side, everyone. At this point, which type of stress is going to develop bending stress, guys, everyone?
Maximum.
Maximum tensile stress.
Maximum, what, guys, everyone?
Tensile stress.
Guys, ask me if you are any doubt, because a lot of theory is going on. So, maximum tensile bending stress. And how we denote that one, guys? F max only. This side also F max, this side also F max. But the only difference is what? Nature. Here F max, compressive in nature. Here F max is what, guys, everyone? Tensile in nature. This is about bending stress. Now, remember, whenever we have eccentric loading scenario, every point is a combination of two stresses. What are the two stresses, guys, everyone? Direct stress and bending stress. But our point of interest is what? Our end points. Our point of interest is what, guys, everyone? Our end points, guys, everyone. What are our end point of interest, everyone? Our end points, guys, observe. So now, everyone, before going further, please add these things in your drawing. And that's why I told you to draw the bigger drawing. Add these things, everyone. Add these two things in your drawing, this one, and draw this figure also, guys, everyone. Now, guys, everyone, write down this discussion. Write down properly, guys, everyone. And beside this drawing, draw this figure also, guys. That our column is going to bend like this, because of the bending effect. It is a bending effect, guys. It is not necessary that column is going to bend like this, but bending effect will be like this. Everyone, draw that one also, guys. Draw that one figure. Now, guys, everyone, try to see the scenario here. You got these concepts also, now, guys, everyone. If we got a negative value, then we will write down positive value, and effect will be opposite direction. But here, so we don't got a negative, so don't worry about this one this time. But you have to remember this one also, everyone. Now, everyone, try to see the scenario here. See, what I told you, two things are important. First is what? F. Second thing is what? M. Once we got a F and M, remaining things are very, very easy. See, now we need a what, guys? Direct stress. Sigma D will be what, guys, everyone? F by A. F is what, everyone? 13.071. into 10 raised to the power 3. Area is how much, guys, everyone? Pi by 4. Outer dia is how much, guys, everyone? Tell me. 0.07 square. 0.07 square. Inner dia 0.054 square. So here we got it, guys. What we will get? Sigma d. Everyone, please do the calculation. Completed, guys, everyone? Now, guys, everyone, please do the calculation and tell me the value, guys, everyone. 8 point, how much, guys, everyone?
0.3388.
8.3, na?
8.38836 into 10 to the power 6.
10 to the power 6 Newton per meter square,
Newton
guys,
per
everyone.
meter.
So it will become 8.3883 mega Newton per meter square. Guys, 8.3883 mega Newton per meter square. So we got it, sigma d. Everyone, what is the 1 minute? I will write down properly. 8.3883 mega Newton per meter square. And what is the nature, guys, everyone? Tell me. Compressive. Guys, this nature is very, very important. So everyone, please write down this discussion of sigma d. Then we will see F max, guys. Everyone.
Excuse me, sir.
Yes, sir.
Sir, as the horizontal component f of x is horizontal, so that's why we have considered it that it is not going to create any compressive forces. Stress or something.
See, how to identify any force is going to create a force? How to identify? Now tell me how to identify any force is going to create a direct stress or not? How to identify? Means which force you have to consider in your calculation. See, now tell me, what is the effect of 10 cos 45? Is it going to compress the column or is it going to bend? What this force 10 cos 45 is going to? It is not necessarily horizontal, guys. Observe, due to this 10 cos 40, what is going to happen? Is it column going to bend or going to compress? Only bend. But guys, effect of these two forces, this 6 kilonewton is going to bend the column also and compress the column also. See the direction, guys, everyone. Here, see this one. This is the effect of 10 sin 45. What is the effect of 10 sin 45? It is going to compress the column also and it is going to bend the column also, everyone. You are getting my point? So you have to see the effect, guys. If it is going to compress, means it is not necessary compression. It may be extension also, guys. In some scenario, guys, everyone. I will take a next question, guys, everyone. Just see. Here, if you observe, everyone. 1 minute. Just observe here in this question. So now, if you observe, this 7 kilonewton is replaced by what? Everyone, tell me. In this question, this 7 kilonewton is replaced by what? Its two component. 7 cos 20 and
7
sin 20.
20.
Now tell me, in this question, guys, who is creating a, now here, this effect of 7 cos 20 is what? Extension or compression?
Tensile
Extension. So in calculation of your 7 cos 20. But now tell me, this 7 cos 20, is it going to create any bending? This 7 cos 20, is it going to create any bending, guys?
No, only tensile.
No, why? It is going to pass through this point only. So no movement create. But now tell me, this 7 sin 20 is what, guys? Is this force create going to any extension or compression of the column? What it is going to create, guys, everyone? Only going to bend. So while dealing with yup, guys, everyone, in this question, yup, only 7 cos 20. But while dealing with yup, 7 cos 20 into that perpendicular distance. So you have to see in such a way to get the value of yum and yum. You are getting my point, guys, everyone? Santosh Dada, you got my point?
Okay, sir.
So you have to see. So here, why we consider only these two forces? Why not this force, guys? Because this 10 cos 45 is not creating a compression of the column or extension, guys. It is only creating what? Bending. But these two forces is what? Along with bending, they are creating what? Compression, change in length of the column, guys. Everyone, try to see the scenario here. So now we got it what guys everyone, written direct stress. For F max we need a what guys everyone, I is what for pi by 64 into d raised to the power 4 minus small d raised to the power 4 guys everyone. So I will become what guys, pi by 64. Capital D is how much? 0.07 raised to the power 4 minus 0.54 raised to the power 4. So everyone, please put values in your calculator and tell me the value of I guys everyone.
So 7.6119 into 10 the power minus 7.
7.6119
10 the power
minus 7.
minus 7
unit
Meter
meter
to the 4.
Okay. Now then Y max will be what guys everyone? Capital D by 2. Then that will be 0.035 meter. Y
Yes,
max.
sir.
160 mm is a height. Y max is related with the dia, na?
Yes, sir.
See this one. Capital D, na? Capital D. So then, 1 minute, guys, don't write anything. Just listen, don't write anything. If you calculate it, then no problem. But if you are not, listen. Then F max will become what guys everyone? M by I into what guys everyone?
Y max
Okay. Then capital M, how much we calculated guys everyone at the top?
1077.8179
0.8174 Y max 0.035 everyone divided by I, how much we calculated guys? 7.6119 into minus 7. So everyone, please put the values in your calculator and tell me the value of F max everyone. Forty-nine point
5587
49.55
87
10 to the power of 6 Newton per meter square.
per meter.
So in mega Newton 49.5587 mega Newton per meter square. So we got it F max and sigma T guys. So before going further, please everyone write down this calculation of I max, F max everyone. Now guys everyone, now try to see the scenario here guys. Everyone don't write anything, don't do anything, just listen words of your teacher carefully. Everyone, what we have to do and how we are going to approach the things further. So now everyone, if you observe the things here carefully, what they are asking us? Maximum compressive stress in the column. Now here, now tell me which point we will have maximum compressive stress. Net, they are asking us overall effect guys. Either left end or right end guys everyone. This side, left side or right side? Because on this right side guys everyone, if you observe, direct stress also compressive, bending stress also compressive, more compressive guys. Everyone try to see the scenario here. Everyone at this point A and B point, so that you should not get confused. Everyone at the A and B point on the drawing. At the A and B point. So guys, at the A and B point, here also add A and B point on this view also. Everyone on this view also add this cross section view. Now observe the scenario guys everyone, what we have to do and how we are going to approach the things further. See the scenario guys everyone. So see, in A part our target is what? Maximum compressive stress. What we have to find out in A part? Sigma max compressive. What we have to find out in A part guys everyone? Maximum compressive stress. So sigma max compressive will become what guys everyone? Will be what? Stress at point B. Maximum, where we will have maximum compressive stress at point B, and net stress at point B will be what? F max compressive nature, and direct stress also what guys? Compressive nature. Below that I will write down nature also, so that you should not get confused. Compressive and sigma d also what guys everyone? Compressive. Guys, try to see the scenario. So then sigma max compressive will become what guys everyone? Maximum compressive stress. F max how much we calculated guys? 49.87. Guys remember, if you want to add two things, remember their unit must be same. Always keep these things in your mind. If you want to add two things, units must be same. If you are using meganewton for F max, meganewton per meter square for F max, then for sigma d also meganewton per meter square, everyone. So sigma d how much meganewton per meter square? 883. 8.3883. 8.3883 na guys everyone? So it will become what guys everyone? Sigma max compressive will become what guys everyone? Tell me.
57.947. 57.947 meganewton per meter.
1 minute guys. How much? 49 point?
Sir, 57.947 meganewton per meter square.
57.947
947 meganewton.
947 meganewton per meter square. So in this way we got it what guys? Maximum compressive stress in the column. And which is at what point guys? Maximum compressive stress? At B point, guys everyone. Please write down this discussion. Now try to see the scenario here. So we will have a maximum compressive stress which is at the point B. Now everyone try to see the scenario. In B part what they are asking us guys? Stress in the column. So means they are asking us overall effect where we will have a maximum overall effect. See, maximum tensile stress. So in B part our target is what? We have to find out sigma max tensile. That is what our target. Now tell me, see, if you consider direct stress is same everywhere, compressive only. But bending stress is a variable. Bending stress is what's going to change. From what guys everyone? Tensile, maximum tensile stress at point A and maximum compressive stress at point B for the bending stress. So where we will have maximum tensile stress guys everyone overall effect? At point A. Because at point A, this is the only point where we have a maximum tensile bending stress. So overall effect of the stress will be what? Maximum tensile stress everyone. So what? Sigma max tensile will be what guys everyone? Tell me. Net effect guys. Maximum net tensile stress where we will have. That is what they want to ask. It will be what? Net stress at point A. F max at point A will be which nature guys everyone? What is the nature? Tensile. And then minus sigma d. So net stress, that is maximum tensile. Guys, so if guys remember, if there is a tensile stress scenario where we will have a maximum tensile stress scenario at a point A guys, everyone. I'm not talking about bending, I'm talking about overall effect. So maximum tensile stress will be at point what guys everyone? At point A. And it will be what? Resultant effect of what? F max and minus sigma d. And this sigma d is in which nature guys everyone? Compressive. So sigma max tensile will become what guys everyone? What sigma max tensile? F max is how much guys everyone? 49.5587. Sigma d is how much? 8.3883. So then what we will have guys everyone? Sigma max
41.1704.
41.1704 meganewton per meter
square.
Remember, if you want to add it or subtract two things, their units must be what guys everyone? Same. If it is here meganewton per meter square, then this term also what guys everyone? Means this, if this is meganewton per meter square, then this term also guys what? Meganewton per meter square. So please everyone write down this B part discussion everyone. Guys, completed everyone? Now tell me, what is your question? Ask me. This 6 kilonewton. What about this 6 kilonewton?
This 6 kilometer is acting on the
Collar.
column,
Huh.
not on the column.
See, it is not necessary. It can act on the column also, guys. Generally, for the loads, we will use a prefer collar. It is not necessary that.
So this is only for showing, not to like 50 mm minus something will come like.
No, nothing. See, instead of collar, you can be on the column also, guys. Huh? Don't worry about this one. Means suppose here, just observe this column. 1 minute. This column. And just have a look at this column, guys. Everyone. Here. This here. See this column, guys. Huh? Observe. On this column, if you observe, F is what? Acting on the column. See, at the end, effect will come on the column only. Don't worry about the collar.
Consider full.
Means collar is the what? Just a rigid body. Nothing to worry about that. But effect of that collar is that forces will come on the what, guys? Column or beam. Everyone getting my point? Try to understand the scenario here. Everyone. Anyone have any doubt in this discussion, guys?
Yes, sir. Yes, sir.
Oh,
Sir,
yes.
Yes, for I calculation, we are taking a cross section of the column. So we are not considering the collar for the finding out the I. So do we need to consider the collar area also, sir? Basically.
To calculate I? No,
Yes,
I
sir.
formula is a fixedness, sir.
Yes, sir. But this I we are considering only the column, but the force is acting some amount
See.
outer the column
See.
of the collar. So we need to consider the collar area also plus this column area, sir.
No. 1 minute. Guys, everyone, remember, there are two types of bodies. One is what? Rigid body. Guys, what? There are two types of bodies. One is what? A rigid body. This is what that you are asking us. For that purpose, I am telling you. Because in mechanics, there are two discussions are there. One discussion is related with rigid body. And another discussion with what? Non-rigid body. Or we will say it as an elastic body. Whenever there is a rigid body means what? No deformation. Guys, you may study this thing, rigid body, in your basic mechanics in first year of engineering. This is the first terms, the rigid body, guys. Rigid means what? No deformation. Whatever the force acting, no deformation. Elastic means what? Deformation is there. So now here, in this case, everyone, remember this discussion. 1 minute. Observe the scenario. What they are asking us in the question, guys, read this question. What they are asking us in the question? Stresses in the column they are asking, na? Is it they are talking about this collar? Guys, remember, always our assumption is here what? There is one our assumption. These collars are what, guys, everyone? Rigid bodies are there. This collar is what, guys, everyone? This collar is what, everyone? Rigid body. And always, guys, our area of, see, whenever there is a column, see, generally forces generally on the collar only. But that effect, the forces on the collar will create effect on, which is create a problem, guys, everyone. Due to that forces, which is going to, where problem is going to create? On the collar or column? Generally, collar will not, if the column is not properly designed, then only it will going to create a problem. It is not a strong material. Collar is generally strong material only. The problem with is what, guys, everyone? Column material. Collar never create a problem, guys. Problem always who is going to create, guys, everyone? No. Column. Column is not a rigid body. Huh? Column, not rigid body. Huh? That is the elastic one. And if you read the question also, guys, what they are asking us? Stresses in the column. Na? If they are saying stresses in the column, then we have to consider only area of the column. Is it they are saying about the collar? Collar, the only purpose of the collar is to take a load. Means generally what we are doing, there is a one surrounding. Suppose if you want to see the top view of this one, guys, everyone, this one. Suppose this is the view of the column, guys. Top view. And this is what a column. And beside the column, we will keep what? One collar around the column. This is what, guys, everyone? Column. And around the column, what we are going to do? We are going to keep a what, guys, everyone? Collar. And don't worry about the collar, guys. Collars are generally rigid body. Rigid body means a strong body. No there is a deformation. Always there is no such concept like rigid body is a myth concept, guys. This is a myth. But we will assume that, guys, what collar is a what? Rigid body. Means we will assume that it is a strong one. But who is a weaker one? Column. And one more thing, guys, if you read the question, what they are asking us? Stresses in the column. Now, if they are asking us stresses in the column, why to worry about the collar, guys? Don't worry about the collar. Our discussion is totally related with what? Column only. So we have to worry about the collar. Because these forces, though they are acting on the collar, though they are acting on what, guys, everyone? Collar. But it creating an effect on what, guys, everyone? Column. Karthik and Dada, you are getting my point?
Yes, sir. Yes, sir.
So don't worry about the collar, guys. Huh? Collar's purpose is only take a load. To give a to take a load only. But that load effect will be on the column or beam. Now everyone, the next question, guys.
Excuse me, sir.
Yes, sir. Yes, sir.
Sir, in this problem, this is an extra question. Just in this problem, can there be any question asked where the f of x component will be in use?
Summation of f of x.
No, sir. The f of x component 10 cos of 45 it will be in use. Is there any question? Will there be any question?
Sir, it is useful, na? F cos 45. F cos 45 is useful, na, here, sir? F cos 45.
No, but sir, in our calculation we have not used it, na?
So in calculation of f we have not used, but calculation of m we have used, na, sir? In calculation of m.
Okay, perfect.
In calculation of m, it is useful, na?
Okay, sir.
Because this 10 cos 45, it is not creating any decrease in length of the column, not change in length. It is creating only moment. It is going to create a only bending moment. So that's why we consider only bending calculation. If it is creating, this 6 kilonewton creating two effect. Bending as well as what, guys, everyone? Compression. So that's why we consider this in calculation of F also, in calculation of M also. For the 10 sin 45, compression and bending. So F calculation also, M calculation also. But this 10 cos 45,
only for movement.
Only for the bending. It creating only bending. No compression is creating. So if it is not creating anything, it is creating only movement, bending. So that's why we are considering in the calculation of the M.
Perfect, sir.
Okay. Guys, any more doubt? Shall we go for the next question? Okay, good.
Sir, you said the note for this clockwise, anti-clockwise in calculating.
Okay, good. Yes.
For the cantilever.
Very good, Michael, sir. You will become a good second engineer. You will not forget important points. See. Very good, guys, everyone. Now, everyone, write down the note. Now, guys, everyone, for cantilever beam or column, for cantilever beam, 1 minute, I am writing. For cantilever beam or column, that is one end fixed and other one is free. Okay. So for cantilever beam and column, for calculating, this note is related. So for this one, for calculating, guys, everyone, what we have to calculate? For calculating bending moment, clockwise moment generally. Clockwise movement is positive, and second, counterclockwise. What guys, everyone? Counterclockwise movement is what, everyone?
Negative.
Is negative. This is just rough note, guys. Everyone, is it more than sufficient? Generally, guys, for cantilever beam or column, for calculating the bending moment, generally clockwise movement is positive, counterclockwise movement is what, guys, everyone? Negative. Everyone, please write down this note.